Have you ever wanted to use the voltage from your PD power bank to make an inverter and power your glue gun? Well, today's video I'll be showing you how to make this 30-watt Type-C inverter that uses a decoy module and can power your light electrical loads. Let's get started. Into the electronics that we'll need for this inverter. Two 110 volts US outlets, 150 watts inverter, that is 12 to 110 volts, you see the voltages there, a 4010 PC fan, it could be 5 volts or 12 volts, a 100 watt Type-C decoy board, 5 amps, a 5x20 fuse and a fuse holder. This fuse is rated for 4 amps, a mini 360 DC to DC step down board, 6 amp Schottky diode, a 3 amp switch and a 10 amp switch. Let's move on to assembling the inverter. Alright, before we start adding the electronics to the case, first we need to do some configuring of these two boards, the decoy module and the DC to DC step down. Now, duly note that if you are using a 12 volt fan, you will not need this module. It is only for the 5 volt fan to step down the 12 volts to 5 volts. Configuring this board is quite simple. You need to connect 12 volts on the input and a multimeter on the output. Using this potentiometer right here, you're going to scale down the 12 volts to 5 volts. That's how to deal with the DC to DC step down board. The decoy module now, because this decoy module has a button that can switch between these 5 outputs, 5, 9, 12, 15 and 20 volts, you're going to have to solder across this 12 volts right here to let it to default to 12 volts, or you could power it up. It will start at 5 volts for you. You're going to select it, press the button, you will go to 9 volts and then press again and it will go to 12 volts. Upon that, you are going to solder S1 just like what I have done. Mine is, you can see, it's not going to move from 12. How to come out of this S1 stage, you have to press and hold and it will start to select again. It's time to start adding the electronics to the case, starting with the fans and circuitry. So we'll need the decoy module, the step down module, as I say, only a 5 volt fan will need the step down module, the switch and the fan. Now, because the switch is on the cover, which is right here, we will not worry about this for now. We'll just leave wires for the switch, the fuse and the other switch. So we first need to screw down the decoy module into its slot. Here are screw holes and here's where the Type-C port will go. So we add that, and as usual with a little bit of magic I screw in the board. Alright, so magic has been finished. Yeah, I have screwed it in. So what we're going to do now is hot glue the DC step down right beside the board where the input is facing the output terminals of the decoy board, right there. Then now, as the schematic shows, we're going to wire the negative from this to this and the positive goes to the switch and comes back down to here. So it's all the 2 wires extra, 2 red wires extra for that. And then this connects directly to the fan. The output of the board connects directly to the fan. To get the soldering done, you realize that here I've soldered it. So if you want to test it, you just connect your Type-C. I see it's on 12 volt and just connect these 2 wires together. Remember, so these are going to the switch. And there it is, there it comes on. Now we are going to screw in the fan. The fan places here. Let's plug out this first. The fan goes right here. Remember, so this is your intake because it's going to blow right onto the inverter, and then you can use another fan right here for outtake. So we're going to screw it in. There are 4 screw holes, but I'm only going to use 2. Looks like my printer needs maintenance. Alright, and again we're going to do some magic and it's going to screw in. Now the fan's installed, it's time to install the inverter. Now we'll be dealing with mains voltage, which is 110 volts. So if you are not a trained professional or you do not know what you are doing, please stay away from this project, because main voltage can injure you fatally / kill you. You have been warned. Now what we'll do now is to wire up the inverter before we screw it down, and I'll show you exactly how to do that. This is how the inverter is supposed to be screwed down, with the high voltage part sitting towards the outlets and the 12 volt towards the decoy module. So how the wiring will go is, although the schematic is there, I'm still going to explain. The 12 volt positive goes from here to the fuse, then to the inverter. The negative goes from the decoy straight to the inverter. Over here on the high voltage side, the negative goes to the outlets, and then the positive goes up to the switch and then to the outlets. We'll be using some thicker 16 gauge wires for this. So let's get soldering. Alright, so I have finished soldering in the inverter and then I screwed it in. Now this may look confusing to you, but remember that there is a schematic for this. So I can see I've finished soldering for this. By the way, you can add a DC 5.5x 2.1 mm jack right here if you would like, and you'd use the Schottky diode to prevent the voltage coming from that to go on the output terminal of this board. So if you want that, it is there for you. So you can have type C and DC, but make sure it's 12 volts. Alright, we're going to add the outlets. All the wires are cut according to where they need to reach, but first, the longer, what should I call this? I'm going to call it like the length of this right here. The longer one is neutral, the shorter one is live. So we're going to wire it up like that. So this is neutral right here. So how are we going to wire? We're going to wire them up in parallel, which they are supposed to be wired in parallel. So I'm going to connect this to here, and then connect these two to right here, so then screw it on. Then also for the positive around it that comes from the switch, I'm going to connect these two together. One goes to the switch and one goes to the other outlet. So I'm going to do that and link back in. You're finished wiring, you're supposed to have 6 wires that go up. So 2 for one switch, 2 for the other switch, and 2 for the fuse. So what I'm going to do now is use screws and bolt these down properly. I'm going to wire this up to the front panel with the switches, fuses, and then show you how it finally looks. Alright, so I've soldered the top panel on. So now what you would add now is add heat shrink on these so they get insulation. I don't have any heat shrink at the moment, so I'm going to add hot glue. But before that, let's test to make sure everything is working. Looking at type C. Alright, the reason why this is blinking is because my PD source right now does not support 12 volts. It only supports 9 volts, so it's blinking, but 9 volts still can use on the inverter though. Make sure the fan is working. You can hear it right there. Make sure the outlets are working. Alright, that came on. The other one, that came on. Alright, so now what we're going to do now is screw it on and close it shut. Remember to add your heat shrink on top. Alright, so after you have screwed it on, you are now completed. So you can plug in this. Alright, so the inverter light comes on red right there, and then the other one is blinking. Let me turn off some lights. You see the inverter light there. And let's test it. Turn on the switch. There. Alright, it's time to run some series of tests with it to see how long it lasts, if it heats up, and all those stuff. Alright, so let's start the testing of the Type C inverter. I'll be using a USB power meter to get the voltage and amps reading. I'll be using this makeshift power bank to be the power source. Here you go, see it goes up to 12. Let's turn on the outlet. You see that light comes on, that light is 5 watts. This is also a 5 watt bulb. This is also another 5 watt USB light. And my USB box fan. The link for this Thingiverse files will be in the description. There you go. It's running all these items, including bulbs, USB items. And you can see it's drawing about 18 watts. Let's turn the fan on. You see here, 19 watts if it will focus. 19 watts.